You're always very generous in introducing me. It makes me feel guilty that I was a little late. We were filming brief summaries of our work, and I was so interested in what I was talking about, it ran a little bit late. I'm going to talk about my title is Improving the Social Security Statement. What I'm really going to focus on is how well people understand their Social Security benefits, and particularly the level of benefits they're going to get from Social Security at retirement, and has the Social Security statement helped them better understand it, or put another way, do they have better knowledge of their benefits today than they did before the statement began being mailed out in the mid-1990s. As Barbara said, I'll just go quickly through. The statement contains a number of pieces of information. It discusses your benefits and the way benefits are calculated. It has a brief discussion of a solvency issue. It has your earnings record. So if there's an error in what they have attributed to your earnings, you can correct it. And I know that happened to a member of my family, so it actually is a useful thing to have. And then it has an estimate of your benefits at retirement, if you have disability benefits, survivor's benefits, and I believe it has the family maximum as well. For retirement, they give you benefits at age 62, the early retirement age, the full retirement age, which is currently 66, and then age 70. This is actually worth highlighting because the numbers are wrong. And this is something where I got to thank Barbara. Because she pointed out when we exchanged presentations earlier, I had relied on a different source of information, which I won't point out, for the rollout schedule, which said it was in different years, the statements were universally mailed to people X age and older. In fact, though, it was based on people's ages, sort of at the time. So, say in 1996, it would have been mailed to people who had been 58 to 60 as of the year it started. So you don't. I'm trying to explain this error screws up my regressions a bit. It does the cross tabulations and all that still come out all right, and I think that's the stuff you'll understand better anyway. But so if there's any problems with my regressions, they're going to be rerun. But anyway, so that just gives you an idea. What I'm relying on here is this rollout. That we had a period before which people were not universally mailed a statement, and then we have periods where people were mailed a statement. So by comparing people's benefit knowledge before and after, we can get some idea of did mailing out the statement help people improve their knowledge. My sort of starting theory on this, well, I had a couple starting theories, was that the Social Security benefit formula, for those of us who work on these things, can calculate, if you give me a spreadsheet, I can calculate my benefits. But if you try to explain it to somebody, the formula is so complicated, they're not even going to understand what you're saying, much less be able to replicate the calculation themselves. So the idea is it's just too complicated to do yourself, so that's why you need the statement to help you. My sort of starting theory is that as we start out universal mailings of the statement, we should get a big bump up in people's knowledge of their benefit levels. After that, one of two things would happen. Either you get smaller improvements over time as people had repeated exposure to the statement, or you would get sort of a fall off in time as people got used to getting the statement and started to ignore it. But I figured you'd get a big bump up at the beginning at least, then we sort of see what happens after that. The question was I right? And as a preview, I'll say no, I was not right. But that was at least what I kind of figured might happen going into things. The approach I took on this was using the Health and Retirement Study, which is a survey of older individuals. They ask a whole range of questions, but one of the sets of questions they ask is, if you have not yet claimed benefits, they ask you to estimate what your future benefit will be. What do you think you will get from Social Security? If you have claimed benefits, they ask you what your benefit is. The trick here is that the same people will be re-interviewed in multiple waves of the HRS, meaning that we have an estimate from before they retired of what they think they'll get. We have a number of what they actually did get when they were retired, so we can compare the two and say, well, how close were you? How accurate was your guess of what you were going to get? One note is that because people can be interviewed multiple times, for some people you have multiple estimates of what their benefits are going to be. I took the final estimate before they claimed on the assumption, which I think is generally true, that at that point people are more informed, they're a little bit more focused about retirement. But so the basic issue, or the basic technique was simply to compare people's estimated benefits before they claimed to their actual benefits after they claimed. And the basic results is around 1/4 of those people who were interviewed, actually it's closer to 1/3 when you add the don't knows and the refused answer. Around 1/4 of people say they don't know what their benefits are going to be. Other people refuse to answer. They won't tell you anything. I've sort of lumped them with the don't knows. So you have a fair chunk of people who just have no idea, really. Of those who do provide an estimate, on average, they're not far off. The median guess is an overestimate of around 4%. At the mean, the average guess is an overestimate around 14%. That comes about because you can overestimate your benefits by an unlimited amount. The underestimate is sort of capped at negative 100%. If you say, I'm going to get 0, and it turns out you get something. But those sort of means and medians hide a lot of dispersion. You know, if you have one person who overestimates by 20% and another person who underestimates by 20%, on average, they're perfectly correct, but each individual has a pretty significant error. 1/4 of people underestimate their benefits by greater than 22%. 1/10 underestimate by greater than 50%. So you have a lot of people who underestimate by quite a bit. On the other hand, 1/4 of people overestimate by more than 21%, and 1/10 overestimate their benefits by 100%. To put that in perspective, I mean, for 1 person in 10, they get their retirement benefit, and it's less than half of what they thought it was going to be. So that's like waking up on the day of your retirement, your 401k is taking a big hit, and you just didn't see it coming. So for those folks, you know, the lack of knowledge about their benefits is a pretty big problem, I think. The question is, does the statement help? And I took 2 methods in looking at this to answer the question of, does the universal mailing of the statement to near retirees reduce these benefit estimation errors? The first estimate is more just sort of cross tabulations and, you know, calculating the distribution of estimate errors for individuals retiring in different years. So you repeat the sort of exercise or the numbers I gave before, but showing them for different retirement years and asking, you know, has our knowledge of benefits improved over time? The second method is using regression analysis to control for changes in the population. The idea there is if you have different characteristics of people in the population that tend to make them more or less literate regarding their benefits, if you can control for that, then you'll get a better picture of the effect of the statement. Because of the rollout issue, some of my regressions will have to be rerun, but there's still some value in them, I think. Here we just show the percentage of don't knows. This is literally people who say they don't know or they refuse to answer. You have a bit of an increase over time and then a fall back to around original levels. The samples are not huge, so I wouldn't overestimate the importance here. But if you take your first group, these are people who were interviewed in the 1994 wave of the HRS and had claimed then. So they made their estimate, 1 to 2 years earlier than that, in 1992, when they're on the verge of retirement. Around 30% of people either said they don't know or they refuse to answer what their benefit would be. And the latest group is 29%. So you don't have a huge difference between then and now. You did have a bump up and a decline over time. But basically, this gives you an idea of people who just can't give you an answer. And they're a group that obviously you should be worried about. Here we look of the people in the 1994 group who could give you or were willing to give you an answer. This gives you the distribution of guesses. And you see you have this big spike right in the middle. It's right around a 0% error. And those are people who came pretty close in guessing what their benefit would be. The folks who are to the left of 0, those are people who underestimate their benefits. The folks who are to the right are people who overestimate them. We cap the overestimates at 400% of your benefits. And again, in theory, you can overestimate an infinite amount, but we say the most we're going to measure is 400%. And you have this big kind of long tail there of a small number of people who have estimates that are really far out there. But so you have a good chunk of people in 1994, this is before the universal mailing of the statement, who have a pretty good idea what their benefits are going to be, and then you have a good chunk of people who overestimate, good chunk of people who underestimate. The thing to remember here is essentially, as a rough estimate or a rough rule, the higher that spike, the more accurate people are, because that indicates more people are centered around 0% errors and fewer out in the tails. So the next slide is will have this line for the 1994 group, but then superimpose the later groups. When I first ran these numbers and took a look, I was a little bit depressed. What it tends to show is you have a higher spike of people towards 0% errors regarding their benefits in 1994 before you had the universal mailing than you had in subsequent years. So this shows that over time we've had some issues. And this doesn't say it's the statement's fault, but it tells you something that is not particularly encouraging about the evolution of people's benefit knowledge over time. Each one of those lines represents a year for the sample, and it differs from year to year, but still it's a bit of a discouraging figure. 5 minutes. I'll move quickly then. This is another way of looking at the evolution over time. What I did is I took the absolute value of individuals' errors. So I said a 20% overestimate and a 20% estimate. I converted them both to a value of 20%. The idea, and then I took the median of those absolute errors. The idea here was to get at some measure of the typical error plus or minus relative to your true benefits and see how that evolves over time. I use other sort of approaches looking at the standard deviation of errors, looking at the mean squared error, looking at the percentage of people who could guess plus or minus 10 or 20%. All of them show the same basic pattern. You had a spike up in errors, in 1996 and later. Beginning around 2000, things sort of declined. Benefit knowledge improved a bit. Errors were smaller. And today, we're about back where we were in 1994 before the statement began universal mailings. So there's a variety of ways you could measure it. They all basically tell this same kind of story. Using regressions, the idea is to control for different variables that might affect benefit knowledge. The dependent variable I use is the absolute value of the benefit estimation error. So you want that to be small as possible. The variables I looked at were gender, race, education, whether the person is Hispanic, and a dummy for whether they were in a cohort that had automatically received the statement. I used a couple other specifications as well, but you get the same basic story. Thinking about some of the variables, increased education or having more years of education was correlated with smaller benefit estimation errors, but not massively so. A person who had a college degree would have about a 4 percentage point smaller error on average than somebody who just graduated from high school, but it was not a massive effect. Race had basically no effect, Hispanicity none really, or no statistically significant effect. Gender, I hate to say for the ladies in the audience, had a pretty big effect. Women were significantly less accurate in their guesses than men were. This is not because men are smarter than women, it's because I think women have a more complicated estimate to make. Many women claim an auxiliary benefit based on their spouse's earnings. So they not only have to be able to guess their own benefit, they have to guess their husband's benefit, and they have to have some knowledge of what the auxiliary benefit formula is. That's a tough thing to make. I don't think that's the only issue, because even if you look at, say, never married women who won't be eligible for auxiliary benefits, they have higher errors as well. But I think there is the case that women have a tougher calculation to make. But the results were that having automatically received the statement had no statistically significant effect on estimation accuracy. So it looked like things kind of got worse over time, but really what the regression seemed to show was just basically no huge effect plus or minus. What I also looked at is does the statement help over time? That it may be receiving the statement for just 1 year didn't help, but if you received it for multiple years, that would help. This is where the problems with the rollout schedule make my regression screwed up. What I did find was that having received multiple copies of the statement did seem to improve people's benefit estimates somewhat, not by an enormous amount, but it did seem to improve them, so that it's not just receiving it once, it's also having repeated exposure that seems to do the trick. But again, I have to rerun these numbers and take another look at it. One question is, why might the effects in the statement be so small? One issue is that, I just got my statement recently, and I remember exactly what the number is they gave me for my benefit estimate. I don't remember what year it applied to. You're getting a lot of numbers there. If you make a small error, you mix up one digit of your estimate, you've got a big problem there. It also doesn't estimate auxiliary benefits for women, which is, again, for women is a huge issue. That makes it much harder to do. It also doesn't provide context. I'm thinking if the statement gave an expression of a sort of a pseudo replacement rate. Here is your estimated benefit, and here's its percentage of your current earnings, something like that. You could say, well, okay, it's 40%, and that's something that sticks in your head and would help you estimate benefits on the fly. Something like that might help. There's also a lot of other information in there, and there could be just information overload. Next steps, I think it's important to continue research on how well the statement has worked to date. In a separate project for the FLRC, I did an exercise where I tested the accuracy of the actual estimation methods used by the statement, where I used earnings records and I said, okay, what would the statement have told this person their benefit was going to be when they're, say, age 40, and then what did their benefit turn out to be? Jason, actually, for SSA, has done a similar sort of paper, and okay, there's a variation in outcomes for a variety of reasons, but on average, the estimates are actually pretty accurate. But one thing I thought would be interesting to do is if you could take the HRS data, that can be matched to Social Security earnings records. From the earnings record, I believe you could produce a number, say, this is what the statement would have told this person at this point in time. So then you have three numbers, what the statement told them, what they guessed, and what their actual benefit turned out to be. That would be an interesting exercise. Then I think we also need more qualitative research in terms of the understandability of the statement. Is it too long? Is it too dense? Should we have pictures? Should we rely more on the internet, which is interactive? I think that's a different sort of track, but I think that's also very, very important. So I will leave it with that, and thank you very much.